YouTube, Brian Phillips here. I've got some goodies. Look at this. That would be a UMX Radian motor. It is a brushed motor, which is disgusting. But it's not going to be disgusting when I put it in this beauty to replace my broken motor. I'm hoping it gives me enough power to fly this thing. However, I'd like to be able to do some sort of an analytical test on this. So what I'm doing is I'm doing the boring, monotonous task of testing before and after. And so I wanted to show you the process I'm going to use. This is a garbage scale from work that I pieced together. And a scale here also from work that was garbage that was pieced together. I work on industrial scales. I've got it set to grams, which is ridiculously high resolution. And I have two batteries here. 1S, 150 milliamp. 25C. We need to validate that these match. So I'm going to show you how to do that with a regular voltage tester. Obviously, it's not going to fit. It's not going to work. So I have to make an adapter, and I'll show you how to do that. That's the first step of our test. Okay, step one. Differentiate between one and the other. Okay? So you got two different batteries of the same classification, and what we're going to do is we just mark them red and we marked them blue. So the next thing is we're going to test voltage and mark it. So if you're trying to copy this build, I'm just using this part number right here, which is a mini JST extension cord, and basically this is just going to give us the ability to use a nice voltage tester to test the voltage on our batteries. So I'll show you how I'm going to do that next. So the first real quick thing you got to know about these, I've been burned one time. That's uno. One time on batteries, and I deal with a lot of batteries. I know some of you guys work with a lot more and a lot bigger batteries, but I've been burned once on a 300 milliamp 1S pack. I cannot imagine how bad the burn would be if it was like a 5S 5000 milliamp. And you know how I got burned? I was unplugging this and these things pulled out. It doesn't take much. I've made a habit when I'm using the female end of these, which is technically a male connector because it has pins, but I'm going to call it female for now. I always put hot glue on these parts to hold it so that it can't as easily pull out. And we're going to not be needing this half, so I'll cut it off. So the first step in our test is to eliminate the male part, even though the male part has sockets inside of its connector, which would make it a female. Okay, so we've got our little patch. Now we just need to strip back the ends, like so. You don't need a ton of cable. You need enough. Okay? So now you've got arguably a pin, or what the starts of a pin would be. And so I'm going to actually tin these, but I'll show you what I'm going to tin them to. I'm going to solder them to a connector, which is going to allow me to use my voltage tester, and I'll show you how I do that. So if you're anything like me, you've got a bag that looks a little something like this, from ends that you cut off of connectors when you had a dead battery, or maybe a battery type that you don't use periodically. You're going to run into these things. And so what I'm doing is I'm just looking for, probably could have used that, but you see it's got dark leads on it, so it's probably got a little oxidation on there. So what I'm going to do is I'm just going to find one of these with a suitable pin size, and I bet you this right here will work for a 1S adapter. You can see I got a switch on there, but I don't need the switch. So let's test it with our little voltage tester. There we go, voltage tester. And you can see it's got polarity listed here, positive and negative. So I'm just going to come down here and I'm just going to see if the spacing is right. You can see the spacing is incorrect. However, it does appear that the pins slide on. So what I could do is I could actually pull out these pins and use it. But let's see what else we have in our bag of tricks first. Alright guys, I found what I'm going to use. These look like tremendously useful tools, don't they? Not exactly. So what I'm going to do is I'm going to pull these out And then I'm going to use these to make my wires that will jumper over to my little voltage tester. So that's the next step. So I'll show you how to do that real quick. I've showed you in other videos, but in this video it's going to be even easier because there's only one wire to deal with. You're going to push down the little tab. There's a little tab. It's going to allow that to slip out. Okay? So you can see as I tug on it, it's holding on to this tab. So I'm using the blade backward. You can use it forward if you want. I prefer it backward. It seems to be a little easier to control. Push down the tab. And you can also use a very small flat-bladed screwdriver if you're nervous about using a knife. So then it just comes out and it looks a little something like this. And then you can use those to actually slide on to your voltage tester. But again, remember I was telling you about getting not electrocuted, about getting burned? Okay, and you can see basically it just bites the side of the pin, and all it is a small flapper that gets pushed up and it's got some spring tension on it. So we're going to actually cover that with heat shrink when we're all done. So my next step is to do it to the yellow wire too, and then we'll actually use some red and black heat shrink just for ease of use. Now since this is just going to be a test rig, and I want these things to line up neatly on the negative and positive terminals, it doesn't really matter which one goes to which, but I'll keep the light color for the positive and the dark color for the negative. I'm just going to actually stick these on there like that, and then I'm going to use that as a gap. It's going to show me what the gap should be so that I can build a fixture to actually hold those together. And I'll show you how I do it. So I just took whatever I found lying around, which was a soda drinking straw, and I stuck the two connection points on, and then I use this to create the gap between those pins because they are quite close. Okay. Now I'm going to trim it up and I'll show you how it looks when it's done. So we've got a little gap maker here, and you can see that that's going to just give us a nice little gap. So we're making our own custom connector here. Okay. So now what we've got is just a little bit of glue holding each side on the top of the connector because the pin's exposed on the bottom. This is going to make our little custom connector. We just filled it up with some glue from the back side there. Just letting it set up. Just hot glue. Nothing special. And then you should be able to, when this cools, you should be able to pull it straight off. But if you pull it too early, then that glue will kind of stick to the pins. So you want to give it a second to do that. Okay, so we've given it a second. Now you can see it holds those pins right in the correct position. And we don't have to worry about bumping them into each other. Now I'm just coloring in the one side red. And the other side I'll mark as black, and that'll help me with polarity when I go to plug it in. Look at that ugly thing, guys. But this ugly thing does work, and it works neatly because you can tell from the polarity on here. The polarity goes to, so this is the positive side, that's the negative. So then you'll just make your alignment on your pins and slide it in. And it keeps everything from ever touching each other, and then you can tell your polarity easily. So remember, the dark color, I just happen to assign that to negative, and the lighter color is positive. Okay, so now we've got to put this end on that end, and that's a pretty easy proposition, but one thought that's usually a good idea is to stagger your joints. And what that'll do for you is you'll kind of have a little bit of an added layer of security in terms of having a short, because then you're not wholly dependent on the heat shrink, you're dependent on a physical gap. So in this case, now I can just kind of line these up, kind of mark roughly where I need to cut, and then cut them. So real simple part of the project here. This is all pretty simple, to be honest. And what this is going to do for us is it's going to help us to protect from short circuit, because short circuits on these, it'll ruin your battery and it can burn you, so you'll just want to be careful about that. Okay, now I'm going to strip these off and then we'll tin them together. Get yourself a little heat shrink. I'm actually just going to match the color because they'll still be ultimately attached to the correct appropriate positive and negative colors, the red and black, up the pike, so you'll be able to very easily transition those colors. So once you slide those down, then you can go ahead and start your soldering process, so you don't forget. It's always a good idea to get those on there right away. Okay, so you guys can see how these wires are kind of just stuffed together. That's one method. You can also tie a knot. It's hard with these little dinky wires, but I've just learned that sometimes with the smaller stuff it's better to just do it like this and just depend on the solder contact. It just depends on your level of comfort with your soldering skills and stuff. The other thing too is I'm noticing that these aren't exactly even for length, so I need to take a little bit off my red, and then I'm just going to slide them together like this, and I'll give you a close-up here. You'll take the red and you'll just slip it. See if I can get the thing to focus really close like this, guys. Okay, that's about as good as it's going to get on this camera. And you'll just slide those things together like so. And what happens is then you can solder those together, and the wicking will actually hold it together. So, okay, so we got the soldering iron set up here. Get the soldering iron clean. Tip saver cleaner. We just have those things pushed together. Just feeding a little bit of solder in there. This thing does not need to be pretty. It just needs to get the job done. And it's probably not going to be pretty. Okay, so we got that side done. Now, one thing you'll want to do is fairly quick order is get this heat shrink pulled up, and you can see what's happened here is that there's a pretty good amount of bump on that solder. What will happen is that will try to protrude through, so you can kind of flatten it. Okay, you'll slip this up right over the top, and then heat shrink that down. And you can do this a million different ways. You can use your hot soldering iron, or you can just use a little flame. This usually, I try to get one side done at a time because it's a lot easier to manage if you have one taken care of. Then you're not tripping over the second one the whole time you're working. Now if you have like 10 to do, then it kind of complicates that theory. It doesn't usually work quite as easy. Okay, so I'm just going to slide these together, guys, just like so. And I'm going to take note of how long this is. And you guys can see how it's got a little bit of extra length on the red, but that's okay. This is the test patch cable. It's not like it's going to be in an airplane, so we aren't going to have a lot of wear and tear from just bouncing around and all that. So this time I can hold it. Just let that solder wick right into your joint there. That's going to give you a nice sturdy joint, even though you haven't tied a knot like sometimes we do with bigger wire. And then this black stuff on there, you'll want to be careful to kind of knock that off if it's not too much trouble. And you're going to just slide your heat shrink over. Looks like we're maybe a little bit wide, so just grabbing between the textured fingers there on the end and just squish it, and that'll actually give us a better crack at success here. One more squeeze from that side there. So we'll just go in there. You go back over it with a soldering iron, but I could care less. This is going to be fine for our test. Okay? And I'll use this in future testing too. It's just nice to be able to know that it's actually getting charged. These little 1S chargers are just crappy usually. And if you want to use your soldering iron to heat up your heat shrink, clean the tip really good. And then what you're going to do is you're basically going to just like, I usually try to kind of ride it. I don't touch it, I just get really close. But I personally think this is a huge waste of time. Some people really like doing it that way. I don't have the patience for it, so I just do it like that. Okay, so now this little test fixture is going to be kind of handy. But remember how we talked about gluing these ends? This end is real vulnerable to popping off. And what I'm going to do now is I'm going to actually turn around and show you how I do that real quick. There, it finally focused. So I got my hot glue gun hot. This is very simple. I'm going to put a little bit of glue here. I'm going to point the gun toward the connector, and then I'm going to wrap around, trying intentionally to get some glue between the joint, between those two wires. And that's so simple, but yet it's very effective. That will strengthen this connection a lot. And then I'm going to take just a little bit of heat shrink, and pick out the ones I need, which is going to be a real common size for what I have with me all the time, it seems like. And my objective here is to actually slip this over the top, so that hot glue needs to be pulled back a little bit, just a little bit too thick. And I'm actually gonna slip that down, and I want it to go just a little bit below the edge, just a little bit below the edge like that. My autofocus is awesome on this camera, guys. Okay, there we go. So now I can heat that up, and what will happen is the glue will hold that heat shrink in place as we do it. See how it's kind of forcing out the glue? That's exactly what we want to happen. So you have a nice sturdy end. Now this end looks like crap too. If you had clear heat shrink, you could probably use that. But in my experience on something like this, it looks so awesome. It's probably just easier to pull it off of your fixture and just cover it with hot glue a little bit, because that'll actually give it a little bit of protection to keep the colors from getting wiped around. She's just going to glue over the top of it and make it look even more clownish. Okay, just like that. Alright, so let's lick the fingers, make sure it's not sticking. It is sticking a little bit. Whoops. So what I want to do, see, I made that nasty texture on it. So what you can do real quick is get that hot and just be done with it, and then leave it for a second. So we'll pause it and we'll do the first part of our testing here. Alright, so that thing's had a second to dry, or to cool rather. And so I'm going to get these two batteries. We got them marked red and blue. So we got volts DC for the different colors. And so the first thing I'm going to do is I'm just going to make sure everything still feels good. It does. We'll go ahead and plug this into the tester first. And negative is the black side, and red is your positive side there. So that's pretty simple. Now we can get a baseline for our voltages. So we got red. You're probably thinking, Brian, just use the same battery. Well, yeah, that's all nice and all, but okay, so we're going to 4.17, 4.17, 4.17. Okay, so the red is 4.17, 4.17 volts DC. We just need to be able to tell that they're the same. They should be the same, hypothetically, but I don't care about hypothetically. I want to know. 4.2, wow, so that's a pretty big difference. So now what we can do is, as we test, my hope is that we can keep them within about 1/10 of a volt for our testing, and maybe the easiest way to do it would be to actually draw down the voltage on the initial testing of this pack, and then we'll be able to move on from there. So as you can see, that's our little test device, which worked out pretty nice. So just took lots of work. The blue battery is the better one. We'll start with that on the brushless, or the brushed motor that we have now. Okay, so this is just going to be a simple thrust test. So you can see it's measuring in, I've got it set to grams, but I've got it set to 1/20th of a gram, or 0.05 grams, which is a very small amount of weight. In this case, this is not a great test, but it's going to be a test for us nonetheless, and we'll be able to make a basis for comparison between the before and after of this motor, and that's going to hopefully tell us if it's going to fly better, because this thing is lacking in power, and so the glide, flying it is kind of a pain in the butt. So first thing we're going to do, now that we've kind of established our voltages, we're going to get our radio turned on. Got a DX18 here. We're going to select the model, and we're going to get ready to, this is ASK-21 UMX, and we'll just go ahead and pop in a battery. We're going to start with the blue battery. Figured we would show you what the weight is. It's 70.55 or 70.5 grams all up. Excuse me, not all up, without the battery. With the battery, we're looking at about 74.8 grams. So that's what we're looking at right now. Okay, so we have the pack in here. We'll just make sure this stays zeroed. It's such a small measurement that it's really kind of hard to keep it from drifting off of zero a little bit. So 74.8. And real quick, we'll actually just switch this to pounds, and we'll 1 pound. So we'll get the equivalent unit of measure. Okay, so that's pretty close. It's 90.8, which you can see that we're really close there. This is a 0.2 pound test weight. Just a crappy old test weight, in fact. But that'll at least give us a baseline, so we can tell that the scale's accurate enough for a test. Okay, so we got everything plugged in, and this is with the blue battery, and we're just doing a simple thrust test. This is going to be 100% thrust, starting from zero, pointed straight over the top. Okay, and we got to kick it to start it. Oh, throttle cuts on. Sorry. So it looks like we're at about 4.6 grams total, which, I mean, you're probably thinking to yourself, Brian, that's ridiculous. First of all, that's not a very good test. And second of all, how are you flying this thing with 4.6 grams if it weighs 74 grams? Well, that's because obviously there's very little efficiency in this test. So we're losing a lot of the air that's being passed by, plus we're pointing it down, and you know, you can see how far we are away from the prop. It's just not a real great test. But let's be realistic. This motor is junk too. So we're going to disconnect our battery. We're going to pop it back onto our tester, and we're going to see what type of voltage we lost in that test too, as another basis for our understanding as to whether or not this is going to be a good improvement. Okay, so we got this thing plugged in. Polarity has been considered, and then we're going to plug this into our tester. And you can see we were at 4. Wow, so we already dropped down to 4.14. That's a lot of load we had on that one little teeny test. So that's, guys, why I wanted to do. So basically my max was 4.60 grams of thrust before. Okay, so now we're going to go ahead and switch out this motor, and then we'll go ahead and do the test again. Okay, so basically this process is fairly simple. To replace one of these motors, the brushless motors are way better motors in general than a brushed motor. There's no parts that touch other than the bearings themselves in a brushless motor. And on these you have bearings, and then you have brushes that touch. And so you have to make contact, and so of course you've got efficiency loss there. But when they're brand new, they work pretty decent for a while. They just don't work long. So if you find yourself replacing one of these motors, it's actually quite a simple process. The first thing you've got to do is you've actually got to break free whatever sort of adhesive you have holding the motor in. And in my case, it looks like I have what appears to be a hot glue. And so what I'm going to do is I'm just going to take and try to just be real careful about my motor leads. And I'm just going to cut. Oh, that's CA. I was going to say I didn't think I used hot glue, but or CA. It might have been just a splatter of CA. And all I'm doing is I'm just getting down to where that motor mount is, and I'm going to cut this free. Because really you don't need that much glue to hold the motors in, and whatever you use, it's likely to get warmed up. So once you get that off, the next step is to, of course, try to pop out the... There's a number of different ways to do it. In this case, I was going to try to come in from the front and push out on the motor shaft, but you just got to be careful not to destroy your plane, because these things are very light and delicate, and you can see I'm trying to bend the nose when I do that, so that would not be the best maneuver. So I'm supporting it more. It's not wanting to move worth a crap, and I'm probably going to break it if I keep doing that. So I'm going to go divert to my backup plan, which is to hold the gear, and I'm actually going to pull off this rubber band. The rubber band, of course, is what helps to retract the prop, so it looks cool, and it also helps to reduce drag while you're flying. So I'm going to hold the gear, and I'm actually just going to spin this off, and that's just going to give us ready access to the motor, a little easier access to it. And also got clear props like this too, but I'm not going to put those on and complicate the test any more than we've already complicated it. Okay, so now I can see better, and I can get in there and touch and manipulate the motor a little bit easier. So I might actually try to grab the motor on the side and just give her a twist. Okay, yeah, there, I could feel it break free a little bit. So I just found wherever I could fit my my grip, got it spinning, and now I can just take and push right up against that brass gear. You see it's wanting to squish and crush it right here, so I'm going to actually hold the gearbox as much as I can. The gearbox is a strong point, and that's what we're pushing against. She's not wanting to move very much, but she is going. And you can see it's popping out as I go. You just got to be super careful, because it is very easy to destroy one of these little UMX planes doing this. So you can see it slid back now. It slid back into the housing a little bit. So now you've just got to continue that process, and at this point I might be able to hold it in a different way, but I'm going to still try to hold on to the gearbox. Just pushing straight and making sure that you're aligned on there. Don't slip off, because you'll rip right through and probably stab yourself. Okay, so there it is. Looks like it's a boy, guys. Alright, so it's popped out now. So now we can just grab the motor and kind of pull it out of the way. Now we have choices here. That's hot glue, it looks like. And I'm just going to try to kind of yank the connector forward, because it's going to be extremely difficult to solder that in its current state. Looks like some CA dripped down and got onto this connector, which is not of great consequence one way or another. Okay, so I'm just going to lay this down for a second, grab some scissors, and this is just hot glue and CA, so I'll just cut it, and that's going to help to prevent from ripping this off the board. That's your battery connector. And incidentally, that reminds me, I need to go ahead and get the hot glue plug back in. First thing I can do is disconnect this quick disconnect, but it would be kind of nice to actually take and remove some of the length of wire. Okay, before I get too excited about removing lengths of wire and things like that, I'm actually going to slide this motor in. This is the new motor. All I did was I pulled off the Horizon Hobby logo. And you're probably thinking, but why are you pushing that in now? What if you need to manipulate it somehow? Well, I'm just kind of having to make a judgment call. It's probably going to be a little easier to do it now than it is later. And you'll just push it. It's real easy to get them in. Then move your gearbox until it meshes, and then you can push it the rest of the way. And when you start seeing the nose bend, you've made it all the way. And the best way to do this, it's not the only way, but it's the best way I've found, because if you use hot glue, the hot glue will actually melt. I'm going to just put one drip, and this is medium, not thin. If you use thin, you're going to burn yourself. And when I say burn yourself, not like literal burn, but you're going to make it very difficult to replace a motor. Okay, so then we'll just get one little kiss of kicker in there, just one little drip, and that will help to set up the glue. quickly, or the CA in this case. Okay, so the motor's in there now, and now it's just a matter of trying to figure out, do we go ahead and try to redo this wiring, or is the wire long enough? And it looks like it's going to be long enough to reach, but then we're going to sacrifice our ability probably to stick the battery underneath the wire, because the wire is going to need to be on the top. And so for that reason, guys, gosh, that stinks. I'm going to reluctantly go ahead and extend this. So let me pause it. Dead motor. It's being kept for a later project. That motor got me by for a little bit. Now I've got my black and my red leads, and I just have to refresh my memory as to what I did color for color. It looks like the black is black and the red is white. Not an uncommon approach. So I'm going to go ahead and get those landed here. I'm going to save as much of this cable as I can, which is also going to lighten our aircraft a little bit. And these little things are invaluable if you work with the ultra micros, so keep those super dinky pins and everything on there.